Have you ever stopped to gaze at the world around you? The bustling cities, the vast oceans, the twinkling stars, and deeply wondered if any of it is truly real, or if it's all an elaborate illusion? The intriguing concept that our perceived reality might actually be a sophisticated computer simulation crafted by advanced beings, rather than an objective, physical truth, has captivated philosophers, scientists, and thinkers for centuries. This isn't merely the stuff of science fiction movies like The Matrix. It's a profound philosophical and scientific inquiry formally known as the simulation hypothesis. It fundamentally challenges our core understanding of existence, consciousness, and the very fabric of what we believe to be real. At its heart, the hypothesis proposes that an advanced civilization, far beyond our current technological level, could develop the immense computational power required to create highly detailed, indistinguishable simulations of their evolutionary ancestors, or even entire universes with billions of conscious beings. One of the most compelling and widely discussed arguments supporting this idea comes from the philosopher Nick Bostrom's famous trilemma, outlined in his 2003 paper, Are You Living in a Computer Simulation?, which presents three mutually exclusive possibilities, at least one of which must be true. The first possibility is that virtually all advanced civilizations, after reaching a certain technological peak, eventually go extinct before evolving into a post-human stage where they possess the capability to run vast numbers of such realistic ancestor simulations. The second possibility suggests that even if advanced civilizations do reach that post-human stage, they might consciously choose not to run a significant number of these ancestor simulations, perhaps due to ethical concerns, resource limitations, or a lack of interest in exploring their past. And the third, most provocative possibility is that we are almost certainly living in such a computer simulation right now. Bostrom argues that if even a tiny fraction of post-human civilizations decide to run countless simulations, the sheer volume of simulated realities would vastly outnumber the single base reality. Given this overwhelming statistical imbalance, trillions of simulated beings versus just a handful in the base reality, the probability points strongly toward us being simulated entities rather than the original, real ones. This mind-bending idea gains further traction from peculiar observations in quantum mechanics, particularly the observer effect, demonstrated in experiments like the double-slit test, where subatomic particles such as electrons behave like waves when unobserved but collapse into particles when measured. Some proponents interpret this quantum weirdness as evidence that our reality isn't fully rendered or computed until actively perceived by an observer, strikingly similar to how modern video games only render the portions of the environment that the player is currently viewing to save processing power. Another fascinating piece of supporting evidence is the Planck length, the fundamental smallest possible unit of distance in our universe, measuring about 1.616 times 10 to the minus 35 meters, which theorists liken to the discrete pixels or resolution limit of a simulated cosmos. Likewise, the universal speed limit imposed by the speed of light, about 300 million meters per second in a vacuum, could plausibly represent a critical processing or rendering cap within the simulation to prevent computational overload. These speculative yet intriguing concepts draw striking parallels between the seemingly immutable laws of physics that govern our world and the technical constraints and optimizations typically found in highly advanced simulated environments. However, despite its allure, the simulation hypothesis encounters substantial counterarguments from skeptics. A primary one is Occam's razor, the philosophical principle that, all else being equal, the simplest explanation is usually the correct one. Positing a vast, intricate simulated reality layered atop an unknown base reality introduces far more complexity, requiring programmers, hardware, and maintenance, than simply accepting our universe as a fundamental, objective one, making the simulation less parsimonious. Critics further contend that the hypothesis is inherently unfalsifiable, meaning there's no conceivable scientific experiment or observation that could definitively prove it true or false, rendering it more akin to metaphysics than testable science. Moreover, the staggering energy and computational requirements to simulate an entire universe down to the quantum level would be astronomically immense, likely exceeding even the capabilities of any imaginable post-human civilization due to fundamental physical limits. The notion of a base reality also invites thorny questions. If our world is a simulation, then what about the reality of our simulators? Could that one be simulated too, leading to an infinite regress of nested simulations without a true foundation? Despite these formidable challenges and critiques, the simulation hypothesis endures as a profoundly powerful thought experiment that relentlessly pushes the boundaries of our understanding of consciousness, reality, and the universe. It compels us to deeply contemplate the true nature of our existence, the astonishing limits and potentials of technology, and the existence of intelligence vastly superior to our own current human comprehension. Whether we are authentic, flesh and blood beings in a base reality or merely sophisticated lines of code within an elaborate program, the relentless journey of philosophical and scientific inquiry itself profoundly enriches and expands our perception of the cosmos. This truly mind-bending idea continues to ignite passionate debate, spark endless wonder, and irrevocably alter how we perceive and question the very fabric of our reality.